Welcome to the Streaming Summit 2025. I will share the topic about validating the streaming system correctness at scale. I'm Penghui, a director of streaming from StreamNative, and now I'm leading the platform team to build Apache Pulsar and build Ursa, which is a stateless and leaderless a Kafka compatible service based on cloud storage, and it can connect the data to lakehouse tables natively. And before joining StreamNative, I'm a software engineer at Zhaopin.com, which is the first Apache Pulsar adoption in China at 2018. And I also helped many companies to adopt Apache Pulsar to help them to find a better solution in unified messaging streaming. Yes, many use cases. And I'm also the Apache Pulsar committer and PMC member. Before I could introduce this project, I want to share the background of this project. Actually, we tried to build the chaos testing for Apache Pulsar before in StreamNative. Actually, verifying the correctness of a distributed streaming system, it's not easy. It's especially under the failure conditions or specific configurations. You need to verify the at least once, exactly once, and the ordering to make sure there is no message loss and no recorder messages. So yes, it's if you just want to write a simple application, one consumer and one producer, it's pretty easy. But if you want to verify the system in scale, for example, you want to verify like 100 producers and 100 consumers, like maybe with 16 partitions or something, actually you need to design a testing system to verify the correctness of this streaming system. So we created a streaming proof project. Actually, it's originally it's for Pulsar, for Ursa. When we build it like Ursa, actually it's changed all the order line implementation. There is no this. We write to S3 directly. Yeah, I mean, it changed a lot to the existing system. So we need a method to testing the new solution or new implementation. So the major reason why we have streaming proof project. And so this framework is just to try to provide a more standardized and scalable solution for continuously verifying those guarantees in the streaming systems. So you can so it can be also used for chaos testing, or any users want to verify the system like before like a production deployment. So the desired goal of this project is try to provide a reliable and a scalable method to verify the message delivery guarantees or semantics at least once, exactly once, and the message ordering for Apache Pulsar, Kafka, or other messaging systems. And it supports to verify like a compatible or Pulsar services just through a pluggable driver architecture. So it's easy to add new drivers to testing new systems. And it's easy to configure what workload you want, how many producers, consumers, or how many cases you want to verify, since they in both Kafka or Pulsar, the ordering is guaranteed by K, or just or partition. It depends on the subscription type. And you can also set the message rate and how long you want to verify. And it also need to provide a real-time monitoring or reporting of the verification state. So, for example, you want to run the test maybe for 6 hours, but if there is any message loose or out of order issues, you should able to get it from the from beginning. Do not need to wait for 6 hours until they test down. And we also need to implement a checkpoint mechanism to compare both the producers and the consumers, like for the correctness validation. It's most for the observability or how easy to debug in the issues. So the framework will also provide clear evidence for any detected issues. It's for example, if the consumer skipped some messages, like you should able to know which message is skipped. So if you have this information, you are able to debug in and to understand what is the root cause. So that is the major goal of this project. And this is also a very simple tool. There is no like a database or some dependencies. It can just run without any dependent services or something. So actually, it has two components. It's one is the coordinator. The coordinator is it's very simple. It will not run any workload. It's just coordinate all the workers. It will try to create producers, create consumers, and to connect it to the Pulsar or Kafka connector. So this is a very simple tool. And so here is the detailed explanation for each component. For the coordinator, it's just to manage the verification lifecycle and orchestrate the workers, and it will also assign the tasks. It's when you define a task, you will define how many additions, how many producers. So it will try to create task and assign the task to the workers, and it will also aggregate the checkpoints from workers. And so actually the verification is done from the coordinator part. So because it knows the state of all the workers. And the coordinator, it also provided the REST API for management and reporting. So you are able to manage your test cases and get any get the test report for any test. Yeah. And the workers is just to execute the producer and consumer test, and which are assigned by the coordinator, and it will also track the local states. For example, for the message sent by a producer or the message received by consumer. And it will also record or detect the errors if there is any unexpected errors. It will also record to the local state, and then the coordinator can get the state by the checkpoint mechanism. And it will also provide a local checkpoint statistics to the coordinator. So it's also by REST API. And the third component is it's a driver. It's just a pluggable driver to interact with the streaming systems. So you need to implement the sending messages or receiving messages to the messaging systems. And there's three key concepts in this framework. The first one is the message key. You need to define how many message key you want to verify in your test. So the message key is just it will be used to identify the partition. Right? If you send a message with a key, the message with same key will always go to the same partition. So also the ordering is typically guaranteed within a key. So the keys are a very important concept. And the second one is the sequence. Actually, I named it sequence. Actually, it's just like the value of the Kafka or Pulsar message. So it's just like monotonically increase the number assigned to each message within a specific key, just like 0, 1, 2, 3. So why we added the sequence? It's because if we use sequence for each key, it's much more easier to detect the either data loss, duplicates, or out of order messages. So with the sequence definition, we don't need to verify the correctness by using any third-party systems, database or something. And the third one is we call like a checkpoint. It's actually just a snapshot of the state for each producer, consumer. It will be used by coordinator to identify any issues, data loss or something. So here is the detailed workflow to start a verification. So first, we need to configure or define the test parameters. We have already explained a little bit of it. So you need to set the driver, the producers, consumers, and yes, it's just the configurations, and then the coordinator will start. It will load the configuration and start to create the topic. It's because it's a create topics should only be done in one node. It's just like one guy to create a topic. And the coordinator will calculate the key distribution, so it can like assign the keys to producers, because like for verifying the matching ordering, we cannot assign one key to multiple producers. That is not possible to identify the ordering issues. And then producers or the worker, it will just try to generate the message with the key and the sequence pair. So it's just a continue to publish to the streaming system. So and the consumer is in the worker. It will just continuously receiving messages from the streaming system, and it also track the, for example, consumers just track the last received sequence for each key, and the producers track the last published sequence for each key, so the coordinator can compare all of them. And the consumer can also detect if there's any duplicated messages or out of order messages, and it's missed message or something. But it's the consumer can only detect the potential data loss issue or out of order issue. But finally, a coordinator will view all the snapshot and to decide if there is any data loss or something. And the coordinator will just periodically trigger the checkpoint request to the workers and to aggregate the producer consumer states to verify the correctness. Yeah, this is the workflow for verifying the correctness of this messaging system. So for the verification mechanism, actually it's like a checkpoint-based verification. It's for a producer checkpoint. It's the latest sequence number of published for each message key. And for consumer, it's just actually we will not manage the so we will not manage all the sequence in memory. For producer, it's simple. It's because we only need to manage the latest sequence number for each key. But for the consumer side, it's because you need to identify the duplicated issue or some issue. But we also cannot manage all the messages in memory, right? So actually, the consumer just making the sequence rich. If there is any messages, it's out of reach, or just for example, for the messages break the order or duplicated messages, and actually consumer just create a new reach. So it can reduce the memory consumption. It's compared to manage all the sequence or messages in memory. And the last one is just to merge all the checkpoints together. And then we can know like which message is duplicated or missed. So let's take some example. For example, detecting the missed messages. Yeah, like what is missed messages? It actually like from the consumer, verified by the consumer, right? Because the producer just keep publishing messages, and the producer will also like I mean during test, the producer will always it's just configured as always retry to publish the message. So yes, it might cause duplicate, right? Depends on like if the message duplication is enabled from the broker side, or either sorry, or for both Pulsar and Kafka. So it's fine. But for the consumer side, actually the consumers should always receive all the messages. So because a producer will not skip any sequence. So for detecting the missed messages, actually we can just merge the regions from all the consumers. For example, if there are two regions from two consumers, the region one is to receive a message from 1 to 5, and the second region is from like 10 to 15. That means the system can identify there is a gap, right? It's a gap from 6 to 9. So that means either like the streaming system has removed the data, or just the data should be persistent, but actually not, right? And it also can be an issue from like the message reading or from the consumer side, just like the message is still there, but the consumer just skip them. So for both two cases, we call missed messages. So if you want to identify it's missed from the writing pass or reading pass, actually you need to do more like investigation. And the second one is how to detecting the duplicated messages. It's just if you compare it to the message loose case, it's very simple. It's message loose case is just there is a gap like between the regions, and the overlapping. Sorry, for the duplicated messages, it's just they are overlapping from two regions, right? For example, we have two regions. So the first region is from 1 to 10, and the second region is from 5 to 15. So we can identify there is an overlap from like 5 to 10. So which means that the consumer has received 6 duplicated messages, and the out of order message, it's the message is which is you received like a message or a sequence, but you never received it before, but you have received some sequence after it, right? So that means the message is dispatched out of order. So for example, the consumer received 1 to 10 before, and then start to receive 15 to 20, and suddenly the consumer received 11 to 13 after they received 20, right? Yes, that means out of order issue. Yeah, but if you like, for example, another example, like if you received from 1 to 20 and then suddenly received 11 to 13, that just means duplicated messages. So it will be a little confusing when detecting the duplicated messages and out of order messages. So there's a tricky part we resolved in this system. It's because like partition reassignment. Because the message from one key, it can be like delivered to multiple consumers. It's because due to the consumer group balancing or something. Yeah, so one consumer can receive a part of the message from a key, and another consumer can receive another part of the key. So actually, we added because you have two consumers, so you must have a mechanism to identify which consumer received which message first, right? something like we need to resolve. We need a way to identify the message receive order. So actually, we added a timestamp-based read creation. So for a consumer, if there is any partition read aside, then the consumer will the new consumer just the consumer like it's the first time it received the message from this key, it will just create a new sequence of read with the timestamp, right? Since the Kafka will not read aside the partition like too frequently, like in 1 millisecond, right? It is not possible. So it just create the read with the timestamp. So from the coordinator part, it can just all try to order all the sequence read based on the timestamp. So it can track which consumer processed which message reaches to identify when when partition ownership changed. Based on the timestamp mechanism, we can detect the potential duplicate or missed messages during the reassignment, as well as the out of order messages. Okay, yeah, here I can give you some example. It's for this case, like it's just to create a verification test. For example, you can have a name and you can also have a driver. Actually, the driver is just it's already support. Now we only support the Kafka driver and Pulsar driver, so it's just enough. And you can also have drivers. It's if you want to this one is added for a geo replication verification for Pulsar. It's because the producer and the consumer will connect it to different clusters. And you can also set which feature you want to verify, and you can also set the topic name, how many partitions, how many producers, consumers, and the message rate, and how many keys, and the checkpoint interval and timeout. A timeout means how long the consumer did not receive the published message. For example, you published message 3 minutes ago, but the consumer still not received that message, which is also not expected, right? So maybe like eventually the consumer can receive that message maybe 1 hour later, but this is not expected. So we will also from the report, you will also say like, okay, how many amounts there? And the consumer delay, it actually designed to verify the catch-up rate. It's because ORSA one is read from the WL log if the consumer always catch up the latest published message. And another case is just lagging back consumers. It will read from the compacted data. We just want to ensure all those cases are working correctly. The last one is the duration. It's just to make how long you want to run this test. And here's the verification summary. It's just a summary report, so it will not have so many. It just have the you can know how many messages has been verified, and like how many missed messages or how many duplicated messages, and you will also able to know the missed sequences. Like for example, for this one, which means the consumer skipped the messages from 844 to 876. So there will be almost 32 or 33 messages have been skipped, which is a case we have detected earlier this year when testing Pulsar. But actually, it helped us to detected many issues related to maybe deadlock or risk condition, which caused the consumer skipped some messages or something, and we fixed all of them. And we used the streaming proof and chaos math in StreamNative. It's a streaming proof. It's just a verification system it will not has any failure injection features or something, but it can work with any failure injection systems like chaos mass, and we can simulate many fault scenarios. For we simulated the Kubernetes fault, kill the pod, and simulate the network issues and CPU strategy issues, I/O issues, and we also can simulate the node failures. So this is the most we use this way for verifying both Ursa and Pulsar in StreamNative. Thank you. This is the talk I want to share today.
Hey, Penghui.
Hey, hi, Cassie.
Hi.
Hey.
Thanks for spending the time and giving us the presentation and being here available to address questions.
Yes, thank you.
Um, we actually get a handful of questions from the audience. Let me read. I know you addressed some of them, but let me still read them so the people who don't have a chance to join the webinar can see it afterwards. Okay, so let's go ahead with the two questions you already answered first.
Yeah.
Okay, so the first one, how does it compare with Jepsen?
Yeah, I mean, it's Jepsen is designed for, I mean, it's not only for streaming system, it's designed for like a database, like any like distributed systems. And so we like developed the streaming proof. I think it's a majorly like two reasons. It's one, it's make it easy to integrate with the SAD, and then we so that we can do like a continuous verification before like any new releases or something like delivered to customer. And the second one is provide a pretty easy way like to troubleshoot the issues. Like if you have any like messages get skipped or get lost, actually it's not easy to troubleshoot. If you use like other systems, I'm not sure. It's just maybe it just like give you like okay, there is something like out of the order or something failure. But for the streaming proof, it can give you like the evidence for like okay, which one is like what is the issue there, and it will provide you like a detailed report to help you to like to identify the issue. Yeah, that is the major two, didn't I think? Yeah.
Okay, great, perfect.
Yeah.
All right, and then next one, does it cover verifying transactions and topic of compaction?
Yeah, transaction is already a roadmap. It's since we are also like working on the transaction support or Ursa. It's all the roadmap, and now we just like support it like at most once and at least once. Yeah, so and for compaction, it's there isn't I mean not spotted yet, but it looks like pretty easy to add. Like now we just like verify to merge in the snapshots like from uh, multiple consumers by like they consume the regions. So for the like compacted data, like we can just merge by case. So it will be like pretty easy to add this support. Yeah.
Nice, nice. I like to hear the word easy in tech.
Yeah.
All right, so the third one, is this framework open sourced?
It's not yet, but we are like working on it. It's I already like checked with CJ and Matthew. It's fine because it's just like a verification tool. But now the issue is like something like we mixed some like CI workflow or something like in Stream Native internals. So we need to like bring them out and make it like a purely 100% can open source. Yeah.
Nice, nice. It's always great to hear that we're contributing back to the community.
Yeah.
Okay, last question we have. Does it very key-based ordering in Pulsar?
Yes, this is spotted. It's actually, if you are looking back to the design of the system, it's all of the correctness verification is based on case, at least once or ordering. Everything is all based on key. So you can define like how many keys you want to verify. Yeah, so you can verify the like a key share subscription, a firewall subscription. You can also like verify geo replication. It's we support like write from one cluster but read from another duplicated cluster to verify like there's no data loss and no ordering issues. Yeah.
Okay, perfect. Thank you for addressing all of that.
Yes.
Okay, so it seems like that's all the questions that we have. And if no more questions from the audience, I want to thank you, Penghui, for being here, making yourself available, and giving the presentation and addressing all the questions from the audience.
Yeah, thank you, Cassie.
Yeah, and then thanks everyone who joined the seminar. I hope this webinar you find useful and insightful. And please remember to take a survey after the webinar to win cool prizes. All right, I'll see you guys in the next session.
Yeah.
Okay, bye.
Thank you.